Hello, this is Jeffrey Fox again. We're doing Big Data Applications and Analytics, the data science course at Indiana University, and we're now into Unit 2, second unit in the Sports Informatics or Sports Analytics section, and it discusses advanced topics in sabermetrics. Here we have our compulsory slide in all units. This is the first lesson of every unit. It's the big data, or the sports analytics ecosystem in one sentence. We use clouds, we run data analytics, or you could say sports analytics. We always collaborate, we process sports big data, and we solve problems in sports informatics, or esports, or sports analytics. These are the X's which are defined in the literature. And this was done when I just looked for informatics. I now realize I should also look for analytics because the field of sports is where I've not seen the term sports informatics used, but I have seen the term sports analytics used a lot. So we probably need to update this magic slide here, which is all the web mentions of the X informatics, of the various values of X. We should probably add X analytics also to this. Let's sort of add it here just to show what we need to do. We need to add X analytics to everything we've already done up to now, both the general term and any specific terms, where it's in sports where the term is defined for an individual value of X. Okay, here's a summary of the unit, which is advanced sabermetrics. It covers the advances coming from using video from these sport vision projects here and from Major League Baseball multimedia efforts. So that's the summary. And the first comes from some brilliant work from Vince Gennaro, who has a blog and a video from the conference, and I've taken liberally from that. This is, as far as I know, unpublished. It's probably too valuable to publish. Worth many tens of millions of dollars, because remember, a win is $5 million. These wins on the margin are when you're getting near the crunch time, when you're going to either make it to the playoffs or make it to the World Series or not. So any way that you can use to improve the chance of winning is very valuable. The value is a lot. A win is worth an awful lot. Remember, the Yankees' revenue was $470 million. And they have 162 games, and about half of those are wins. So dollars per win is it's all more than millions of dollars. And according to Vince, it's 5 million, at least for the important wins. All right, so this work is on clustering pitchers. And it basically shows how to use the stuff that is originally designed for Netflix and Amazon to study pitching. And probably the best reference is this blog here. And we will give the link to his video a little later on. So here we have, remember I pointed out many times, a critical thing about any of these fields is you need the domain expert here, the baseball expert. Vince, although he's he's a very distinguished financial person, he actually is a baseball player, and you need the expert to choose what things depend on. Like, these are the features. We had that at the example of the last lesson of the previous unit. So these are these features. These are the features that are important. They, of course, are relevant to hitters because the purpose of hitters is to hit pitches, which pitches come from pitchers. So here you have the fastball velocity, which is answering how fast does he throw. Here is the movement. How much the ball moves when it goes from the pitcher. You can predict the straight line, and then you can predict actually what happens with breaks and curves and things like that. And then these various pitching styles. Often pitchers There's not only the style of an individual picks, but also the correlation between one pitch and the next pitch, and where they appear in the plate and the hitting zone. So these are all the parameters of relevance. Is actually where he releases it. Okay, so you and of course pitches is very important whether you're left-handed or right-handed. And some pitchers, and actually that is whether the pitcher is left-handed or right-handed, or the batter is left-handed or right-handed. And some pitchers, and I have no idea who these pitchers are, they approach left and right-handed batters very differently. And points out this fellow Weaver has totally different pitches, top pitches against right-hand batsmen and against left-hand batsmen. And you can not only change the type of pitch, but you can change where you release it and their movement, how much they dodge around. And so you have to classify separately the performance of pitchers against left and right-hand batter. And actually, that's going to end up pretty important because you might find a particular pitcher is wonderful against right-handed batters, but useless against, no, not so good against left-handed batters. And that will tell you when you're having a star left-hander coming up, which pitcher you bring in. So this points out here, which we've already essentially said, there are 4 categories: right hand against right hand, ... left hand versus left hand. And these are categories. We'll do all the analyses of clustering in these 4 categories. So we're trying to find, at least Vince is trying to find out, for a given batter, which pitcher to use, or in the same, it's actually almost the same problem for a given pitcher, which batter to be used. And of course, this comes up when you're putting together the team. If you know you're going to play a particular team, you can at least you'll know most of the players on that team, and so you can just see whether you can analyze the performance of your pitchers against those teams, and therefore you can decide which for the team is best suited. That will be a starting pitcher. For a relief pitcher, you'll be much more precise because the relief pitcher is likely to face 3 or 4 very particular, or 1 through 4 very particular players, and so you can look at those 1 through 4 particular players. And one way of doing this, which is to look at the previous record of the pitchers versus the batter, and what this analysis is trying to do, a recommender engine, effectively define for a given pitcher which pitchers are similar. So here it says these pitchers here are all pretty similar against right-handed hitters, and that's based on this profile. So you look at the profile that's represented by a feature vector. You plot those feature vectors in a space for right-handed batters, and you will find they fall relatively close to each other. And the big idea about this is when you have a group of pitchers who look similar, you can look at the performance of a given batter against that group of pitchers, not against an individual pitcher. And this allows you to get much better statistics and probably a far more reliable prediction as to how that pitcher-batter confrontation will emerge. So here is, now we come to his YouTube. The previous things were from his blog. So effectively, the material described in this blog is actually on a YouTube video, and these things are just clipped from the YouTube video. And he points out that what he's doing is he's got the new data. This is the pitch FX, which is giving him the information which he needs. The hit FX, which is telling you this is for the batter and this is for the pitcher. Batter. And he happens to use, I'm sure he doesn't need a graph database. There really isn't that much data, and the graph part is not important. So he could use a database. You could use HBase if you wanted to. If somebody wanted to pay me a modest amount of money, I would reproduce this with HBase and Spark and things like that. and because we have very good clustering algorithms and better than I'm sure Vince does. Okay, that's a slight aside. So anyway, they're gonna use the built-in analytics of Yark Data, which is a Cray product running on a Cray machine with Cray software. Yark Data was a company purchased by Cray running on a shared memory machine. Ours would all run on distributed memory clusters using Giraffe or Spark or what have you as the underlying technology. And they say the goal is to cluster pictures by their similarity. So here is a nice picture of what you get. We will come and discuss some of these outliers, not actually for this. This is left-handed pitchers against right-handed hitters. We actually go into more detail. This comes actually from the blog. We'll follow actually the YouTube, because that YouTube goes into a little more detail than the blog. And the YouTube is a different quadrant of the four possible handedness of pitchers and batters. And similarity is represented by a line here. But actually, if you're clustering, you don't really need those similarities because the distance is actually representing the similarity. So I think these lines are slightly misleading, in my opinion. I don't think they're useful. What counts is that, these are similar pictures. These are similar pictures, and so on. These are very similar pictures in here, and they're also very distinctive. These ones are very far apart. These two, of course, relatively close. And up here, there's a bit of a mess. There are a lot of quite close pictures there. Of course, this is a two-dimensional projection. Typically, you visualize these in 3 dimensions. We've shown that with PlotViz. And the features, remember, I forgot, there were 12 features. So these are 12-dimensional vectors clustered in 12 dimensions and projected on here to 2 dimensions. And this is the classic thing you do, and we've done for a million sequences. And here we have a relatively small number. I mean, this is not a big data problem, in my opinion. It's a big data conceptual problem. It just doesn't involve a lot of data, in my opinion. But I'm biased. So here they just have names. This is the red and the orange were close together at the top. So here are these, here is actually a pretty similar set. They're right at the top. Maybe you should include those. They are probably relatively different from these and these. So depending on the accuracy, you'll use more or less, you'll choose clusters of different sizes. Because hopefully the way this is plotted, the distance between the pictures is proportional to the distance they are in feature space. You go to your feature space, 12 dimensions, you calculate the distance from the values of those features for each of those pictures. And then you can just calculate the Euclidean distance in 12 dimensions, possibly normalizing each feature to have mean of 0, an average of, and standard deviation of 1. That's so-called whitening. And that's a very well understood thing to do. We can do that in the blink of an eye. This could run on a laptop. All right. Here we have so that previous was the blog, but the real action was done on the YouTube. He actually produces some answers. And here is actually a different set. This is right-handed pitchers versus left-handed batters. And here he has just 2 isolated pitchers. These are so-called knuckleball pitchers. Mr. Dickey and Wakefield, very famous. They're very different. You can see how this particular style of a knuckleball pitchers gives you a very different, totally isolated cluster. You can't probably find anything from these other pitchers about how batters would play against them. However, these are all the same and so on, and these are pretty similar and so on. So we have lots of clusters. And here he's actually, I did some clusters. We'll add this one because it's obvious, too obvious to put in. But anyway, he's given his version of the clusters, which are not terribly different from mine. And now he's going to look at this one in more detail because he's going to find he wants to look at pictures, a couple of pictures in this set and see how they look. All right, so here we are. Here's this bottom left cluster. These are turned out that have high velocity fastball, a relatively low pitcher variety, and they deliver in the upper half of the strike zone. And notice that this is actually interesting because when you plot things in or in this case 2 dimensions, maybe he has a 3-dimensional version. I would certainly use a 3-dimensional version in my analysis. You can't always do this because these are only 3 of the features, but you have 12 features, and it's actually all 12 features which is forming your discrimination. These are just some of the highlights and maybe the most important aspects. If you were doing a principal component analysis, which is not, in my opinion, the best way of doing this, you would look at the eigenvectors, which say we would look at the top few eigenvectors and see what the coefficients of the various features which were large. This is how you deduce this type of thing. Anyway, maybe we need a better discussion of how you do this in general, because that's sort of what we do for a livelihood. So they looked at the particular example of the Yankees versus the Rockies, and you wanted to choose which Yankee right fielders to put in the team, and you knew you were going to face a particular pitcher as the starting pitcher in this game. And this pitcher was in one of that cluster which we were just looking at. And unfortunately, if you take a particular right fielder like Suzuki, he has not played very much against any individual pitcher. And however, if you look at all he has, if you look at this entire record against this cluster, it's quite high. Notice this is the Istvan Nicasio, which I don't think he even, don't actually know whether he played, whether it was 0 for 6 or whether that which of these represents. It looks as though it's the one above there, so maybe he never played against this particular pitcher. But if you look at his total record, there is really not very good, and he's in the 30th percentile. And there's another right fielder, possible right fielder, Brennan Bosch, who they could play, and he, when you do the same analysis, in the 60th percentile. So this tells you, you just take, instead of just taking this one pitcher and ask how the person did against this one pitcher, you take all pitchers in the cluster. And you can do this in a very systematic fashion. You put all your batters here, and you put all your possible pitchers there. And you'll find, for instance, Suzuki looked pretty terrible against Nicasio's cluster. He's pretty good against Jeff Francis or Tyler Chatwood. Whereas Brennan Bosch is, and actually Ben Francisco is also not very good against these 2 pitchers, whereas Brennan Bosch is good against both of these pitchers here. He's also obviously a pretty good player because he's not too bad against these other ones here. So, but Suzuki, you would obviously play when Francis or Chatwood was pitching, and Bosch, you could also play him in these circumstances, but you would certainly play him against De La Rosa or Nicasio. So that's the idea of looking at average performances over the cluster. Looking at that average performances, you can choose recent performances because that's the most likely, because pitchers and batters change with time. Batters, their styles change and their velocities change and things like that. So if you average over too many years, you're going to get the wrong answer. So that sort of summarizes the change. The old process was one-on-one. You took each batter against an individual pitcher. Now you look at multiple pitchers. You then get a much better sample size. And you look at, even if you had no data against a particular pitcher, you can have data against other pitchers. Even if there was data, it could span 15 years. Here you just limit your the data you use to the last 3 years, say. And you can also use better sabermetrics, so you'll use these fancy sabermetrics measures of performance. Which is, you could do that anyway, even if you're doing the one-on-one. But the old process didn't do that. So this is really pretty powerful, and it shows how, and you can also imagine doing this, say, for cricket, where again, at least the core thing is, again, it's not dissimilar in terms of it being one-on-one. There's a bowler going to a batter. There's a batter hitting the ball, which is very different depending on how the ball is pitched. Sorry, thrown. Bowled. Sorry, bowled. Bowlers bowl. They don't pitch. And they certainly don't throw. Bowlers are not allowed to throw. They have to have a straight arm. You're not allowed to. You have to have your arm with no kink at the elbow. Otherwise, you get forbidden in cricket. Anyway, cricket is pretty as a sudden, not only similar issues to look. I mean, to a naive person, it's similar to baseball. I think you could do all of this analysis for cricket, and therefore we should all move to India, where cricket makes money, and do this analysis, and then we needn't screw around. So that's the end of this particular lesson, and we'll go on to a little more I have to say how happy how much I depended on Vince Gennaro, who I listened to a talk. I was very impressed by a talk he gave at the conference I went to, and I tried to find out as much as possible from the web so I could tell it to you in a reliable fashion and not rely on my scruffy rubbish notes. So here we are. Thank you.